This is the Capacitor Visualizer project. The circuit consists of a 9-volt battery and adapter for power, a yellow LED, a bicolor LED, three 470 ohm resistors, a 1 millifarad capacitor, and two momentary buttons. An original prototype circuit was made on a breadboard. The components were then transferred to a printed circuit board and soldered on. After that, the PCB was screwed into a custom 3D printed case. When the charge button S1 is held down, current flows into the first two resistors R1 and R2. The yellow LED illuminates as current is flowing through its leads. The capacitor begins to charge up very quickly at this point as current is flowing into its anode lead. The bicolor LED illuminates red because a bit of current is passing through the capacitor via induction, providing enough potential difference between its leads for it to turn on. It fades very quickly though because as the capacitor gets fuller, less current passes through it. This process is demonstrated here as S1 is held down. When S1 is released, the circuit is no longer connected to the positive terminal of the battery. The capacitor releases its charge and current flows from its anode lead through R1, into R2, through the yellow LED, through the bicolor LED, and then finally to its cathode lead. The yellow LED remains on as current from the capacitor is passing through it. The bicolor LED turns green because it is positioned so that if current is flowing from its shorter to longer lead, it will turn green. Both LEDs begin to fade out instantly after S1 is released as the capacitor begins to lose its capacity. This process is demonstrated here as S1 is released. When the discharge button, S2, is pressed, the capacitor's leads get joined by this resistor, R3, quickly draining it, so both LEDs turn off. This process is demonstrated here. This project demonstrates how a capacitor works.